Good morning, everyone. I'm Shubham, and I'm a solution consultant at UBOps. The theme that I'm going to talk about a bit briefly is around deploying AI applications. So there's a lot of things happening in healthcare, especially on AI. So a lot of different kinds of application, from imaging diagnostics to drug discovery to automating clinical trials. Lots of domain they're trying to apply AI in different shape and forms. Like this is the, let's say, the broader category. Oop. However, there's a very interesting question that I would want you to think about. Can anyone guess what this number might be? 87. We're talking about AI applications.
Certified?
Sorry?
Certified AI application.
Well, it's actually more. There are like 672 certified radiology applications. Percent of AI projects typically fail. So this is not only around healthcare, but it's overall statistics, and it's a little bit outdated, like 2020, so I don't have the recent data. But to think about it, if you're a data scientist or if you're a company and around 85% of your work is going to go to a garbage, you can think about this as a huge waste of resources, and as a company, a huge cost. And we try to think about why exactly is that happening. Our logic is a lot of companies don't really understand the ops part. So if you look at building machine learning applications, there are different stages. So like in DevOps, usually it's dev and ops part. But in building ML application, typically there are 3 stages. So designing, development, and operations. In design part, you more on research your use case, what you're going to build. You look around the data. In model development, you're doing more on the data engineering side, experimentation and validating. And there's the operation part where I would talk a bit more. Now, when we translate this to healthcare, typically there's a lot of difficulty in the design phase around data access. So most of the time, you cannot actually get right data, or there are privacy or legal issues. When you're designing your algorithms, there's a lot of problem around consolidation. So every institute or every organization stores data in its own way. You need to transform them into one unified pattern. There's ethical and legal concerns. There are data errors that you need to fix for. What we have seen is in last few years, the design, sorry, there's a typo there. So it's a model development phase in the second one. So in the model development phase and design phase, there's a lot of progress. But on the operation part, when you actually have built a model, deploying is still lagging behind. Most of the time, it's around the model quality. So you design for certain patients or certain segment, but the model started drifting. Do you have a safety or fallback mechanism? There are issues around reliability and governance. Now, when we talk about the ops part, typically we hear that hospital, they are not sure about the privacy or security of how the AI application is running. A lot of time, the IT team will end up, even though you have built a very good application, IT team will send up this, the infrastructure is too complex. I cannot handle it for scale or for all the patients. Then there are challenges around the cost control. Okay, who is going to pay for all this, or is it in a budget? And then when we talk to researchers, one of the core challenges is it's a very iterative process. So once you have deployed a model, it's for sure performance is gonna degrade. So you need to retrain it, or you need to have an easy way to again improve your model. And this iterative process, most of the time in organizational setup, it fails. They don't have a very easy way to update their models. To solve this problem, we build a stack. So we build what we call as UBOps MLOps stack. So what you see is in a machine learning lifecycle, there are like the first few parts, so from data management to data labeling and data building the notebooks and experiment tracking. That part has already been covered by a lot of companies, and there's a lot of work already done. But the part where you need to do the ops, where you need to do a model training, Most of the organization, they don't have either skills to maybe hire platform engineers or DevOps engineers and make sure that it continues or keeps running without problem. If your DevOps engineers quit, suddenly you don't know how to manage this. So we built a vertical integrated stack so that companies who don't have all the AI skills, they can build these applications very easily. So what we provide is we provide from the infrastructure out of box. So if you have a data scientist or companies who have data scientists but they don't know how to scale or build their application to live, we provide out of box IT infrastructure. And especially in healthcare setup, every hospital, they might have their own cluster, they might have their own IT tooling. Integrating them is a really problematic. So we built custom or specific agents so that we connect to different hospital infrastructure and make sure that these applications get deployed easily. So that's one of the core features. So we unify all sorts of infrastructure. So hospital, if they have their own local system, a local cluster, we connect to it and let the AI application run there. But if there's a more workload, it could also scale to cloud or to different sorts of infrastructure. We provide a clear architect because most of the time IT teams are the really difficult people in hospital to convince to get the adoption. So we provide a clear architecture documentation around having IT teams control over AI applications. And then the other thing that we really built with healthcare in mind was around pipelines. So now that I mentioned that, usually it's a very iterative process, and if you are deploying any healthcare algorithm, you would also want to test it, let's say, continuously, so keep it improving. We made it really easy for teams to combine different algorithms together and test it via pipeline. So what you see here, if you have a ML model and you want to test that on, let's say the first 100 patients should go to a model A and the other next 100 should go to model B. We made it really simple for data scientists to do that. So this really helps them to accelerate testing and validating even though the model is in production, to build their application live. This is just a use case or like an example from one of our customers who build an immunotherapy application. So they predict whether a treatment is better or not, is a right treatment for a patient or not. And they use like the clear statement from them is without using UBOps, it would take them a lot more time to actually build the application, but also manage and scale it. In short, building AI part of proof of concept is very easy. Scaling and managing and making sure your application runs seamlessly is still a dream for a lot of organizations, and especially smaller organizations who don't have all the expertise and financial, basically money to scale them. We provide out-of-box IT infrastructure so they can build and they can become an AI organization. Yeah, so that's in short my presentation. And yeah, these are some of the typical customers from healthcare that we work with. Yeah, any questions?
We have 1 minute for question.
I guess it was super clear. All right.